At 6:13 on the morning of October 1st, 2015, the American cargo ship El Faro lost propulsion near the center of Hurricane Joaquin. Her main engine could no longer maintain oil pressure. The ship was already listing heavily to starboard. Water was rising inside cargo hold number 3, and the pumps were not keeping up. Outside, a Category 3 hurricane was driving waves across the deck. 33 people were aboard. The captain would order everyone to wake up at 6:31, but the general alarm would not sound until 7:27, 74 minutes after the engine stopped. By then, the ship had lost almost every option it once had. El Faro was not destroyed by one isolated failure. Her loss was the end of a chain. Delayed weather information, rejected route changes, worsening seas, flooding, a deepening list, and finally, the loss of propulsion. Each link reduced the value of the next possible escape. To understand how that chain formed, we have to go back 35 hours to a calm evening in Jacksonville, when the hurricane was still far away and the ship still had room to turn. El Faro was a United States-flagged cargo vessel running a regular service between Jacksonville, Florida, and San Juan, Puerto Rico. On the evening of September 29th, she carried 28 American crew members, 5 Polish riding crew, and 11,046 long tons of cargo. Her final line was released at 8:07 p.m. Under normal conditions, the voyage was familiar. The direct route ran southeast from Florida, past the eastern side of the Bahamas, and toward Puerto Rico. But that evening, Tropical Storm Joaquin was strengthening near the islands. At 4:51 p.m., a little more than 3 hours before departure, the National Hurricane Center announced that Joaquin could become a hurricane the following day. The storm was not yet a hurricane. Its future track was uncertain, and uncertainty did not automatically make the normal route unsafe, but it did mean that the route would need to be tested repeatedly against new information. Before departure, Captain Michael Davidson said he intended to use the normal direct route. The second mate noted that passages through the Bahamas could be used if conditions changed. There was no single unavoidable path. The ship could remain on the direct route, turn south through Crooked Island Passage, use the islands for partial shelter, or reconsider the voyage as the forecast developed. El Faro sailed on the direct route. At that moment, the decision was not irreversible. The danger lay in what would happen as the storm moved, and in how quickly the ship's mental picture of that storm would be updated. Weather information aboard El Faro did not come from one source. The bridge could receive National Hurricane Center products through systems such as Inmarsat Sea Safety Net. It also used a commercial program known as the Bon Voyage system, or BVS, which displayed weather information on a chart. The problem was timing. The tropical cyclone data inside the BVS email files was already about 6 hours old when those files were published. That did not make every part of BVS wrong, but it meant the storm position displayed on its map could lag behind the most current National Hurricane Center advisory. More recent information was available through other shipboard channels, but the clearest visual product on the bridge was showing the storm where it had been. That distinction mattered because Joaquin was not following a simple, stable forecast. It was strengthening and shifting while El Faro continued southeast. A 6-hour delay did not merely change a symbol on a screen. It changed the distance between the ship's planned track and the hurricane's actual center. The crew therefore faced two moving objects, the ship and the storm. Every hour without a decisive change reduced the sea room available for the next decision. Late on September 30th, the third mate reviewed a new forecast. At 11:05 p.m., he called the captain and reported that the hurricane's eye was now expected to pass roughly 22 knots. Opportunity to reassess the plan. The captain did not come to the bridge, and no course change was ordered. El Faro continued along the direct route. It is easy to look backward and treat this moment as an obvious final chance. It was not the final chance, but it was one of the last moments when a major route change could still be considered before the ship entered the worst conditions. The cost of turning was increasing, while the benefit of staying on course depended more and more on the storm behaving as expected. After midnight, the second mate worked on another option, a turn south through Crooked Island Passage. At 1:15 a.m., a satellite radio broadcast announced that Joaquin had become a Category 3 hurricane. 5 minutes later, at 1:20, the second mate called the captain and proposed the southern route. The instruction was to continue on the existing track. Two officers on two different watches had now raised the changing storm, and the route, the direct route, remained unchanged. The investigation would later identify ineffective bridge resource management and the captain's failure to adequately consider the officer's suggestions as contributing factors. That finding does not prove malice, panic, or a desire to endanger the ship. It describes an operational failure. Important warnings were present, but they did not produce a strong enough change in the plan. At approximately 1:30 a.m., El Faro moved beyond the wind shadow of San Salvador Island. Until then, the island had provided some protection from Joaquin's strongest winds. Once that shelter fell behind, the storm stopped being mainly a forecast problem and became a physical force acting on the ship. El Faro began losing speed and developing a starboard list. At 3:24, the second mate observed that the ship was heading into the hurricane, but by now, turning was no longer the same maneuver it would have been hours earlier. Heavy wind and seas reduced speed, increased the list, and made every major change of course more difficult. The captain arrived on the bridge at 4:09. At 4:45, he downloaded a BVS weather file that had been waiting since 11:04 the previous night. The storm position in that file still relied on older National Hurricane Center data. A newer BVS file became available later, but when it was downloaded at 6:09, its tropical cyclone position was also behind the most current information available through other channels. At 5:43 a.m., the bridge received a report of water in cargo hold number 3. El Faro's speed had fallen to approximately 2.8 knots, and the ship was listing about 18 degrees to starboard. A watertight scuttle on the second deck was open, allowing water to enter the hold. Crew members struggled to reach it in the worsening conditions. The scuttle was secured at around 6 SAR, but the water level did not fall. The investigation could not determine why the scuttle had been left open. It also found that the flooding cannot be explained by that opening alone. Damaged seawater piping contributed additional water. The arrangement used to secure vehicles in the hold did not meet the requirements of the approved cargo securing manual, increasing the risk that vehicles could shift as the list grew. The crisis was changing shape. Hours earlier, the central question had been whether to alter course. Now the crew had to fight flooding, control the ship's stability, protect cargo, and keep the machinery operating at the same time. The sustained list affected the main engine's lubrication system. According to the National Transportation Safety Board, the list contributed to low oil pressure. At 6:13, El Faro lost propulsion. The main engine could not be restarted. This was not an unrelated mechanical failure arriving at the end of the story. The route, the hurricane, the flooding, the shifting weight, the list, and the loss of oil pressure had become one connected system. Without propulsion, El Faro could no longer turn her bow toward the seas or move away from the hurricane. The ship was now drifting in extreme conditions with water rising inside her. At 6:31, the captain ordered that everyone be awakened. The general alarm still had not sounded. Beginning at 6:59, the captain tried to reach company officials and emergency contacts ashore. He reported that El Faro was taking on water, listing heavily between 7:12 and 7:15. Satellite distress messages were transmitted. The United States Coast Guard received an automated alert at 7:15. But receiving a distress signal did not mean rescuers could immediately reach a disabled ship inside a hurricane. El Faro was near the Bahamas, surrounded by conditions that would turn the area into a vast and dangerous search zone. At 7:27, the general alarm finally sounded. 74 minutes after propulsion was lost. 1 minute later, the crew was ordered to muster on the starboard side. At 7:29, the order was given to abandon ship. Containers were reported going overboard. The heavy list and violent seas made the survival craft extremely difficult to use. The voyage data recorder ended at 7:39:41. The recording does not tell us exactly where every person was after that moment, or precisely what happened during every attempted evacuation. Those final actions cannot be reconstructed with certainty, and they should not be invented for drama. El Faro sank approximately 40 nautical miles northeast of Acklins and Crooked Island. All 33 people aboard were lost. Joaquin was a Category 3 hurricane during El Faro's final hours and strengthened to Category 4 later. The distinction matters. The story does not need a stronger storm than the one that was actually there. Category 3 conditions near the hurricane's center were already beyond what the damaged and disabled ship could survive. The main wreckage was found on October 31st, 2015. At a depth of approximately 15,410 feet. But the device that could reveal what happened on the bridge, the voyage data recorder, remained on the seafloor. It was located during a later expedition and recovered in August 2016. The recording allowed investigators to reconstruct the changing forecasts, the route discussions, the flooding, the machinery problems, and the final emergency in extraordinary detail. The NTSB, its probable cause was not described as one bad decision or one broken component. The board cited the captain's insufficient action to avoid Joaquin, his failure to use the most current weather information, and his late decision to muster the crew. It also identified ineffective bridge resource management and the inadequate consideration of officers' route suggestions. The investigation extended beyond the bridge. It identified deficiencies in TOT's oversight and safety management system. It examined the open watertight scuttle, damaged seawater piping, cargo securing, down flooding through unsecured ventilation closures, the loss of propulsion, and survival craft that were not suitable for the conditions. At the same time, investigators did not find evidence that the company directly ordered the captain to sail into the hurricane. The captain's private motivations cannot be known with certainty. The official findings are a safety analysis, not a criminal verdict or a psychological diagnosis. El Faro's loss did not begin at 6:13, when the engine stopped. At departure, there were several possible routes. At 11:05, there was a new warning. At 1:20, there was a proposed turn to the south. Then, the shelter of San Salvador disappeared. The route problem became a heavy weather problem. Heavy weather became flooding and stability problems. The list contributed to the loss of oil pressure, and the loss of propulsion removed the protection offered by the next. Safety at sea does not depend on one perfect decision. It depends on layers, current weather information, a bridge team able to challenge a plan, properly secured cargo, closed watertight openings, reliable machinery, usable survival equipment, and an alarm sounded while there is still time to act. On El Faro, those layers did not save one another. What remained was a ship on the seafloor, 33 lives lost, and a record of how a disaster can form long before the final emergency becomes visible.